All right, we're going to go ahead and get started. Thank you, everybody, for coming out. So my name's Greg Gibby. I'm with AMD, and I lead our software-defined infrastructure solutions group. And today we're going to talk a little bit about containers and the advantages that AMD brings into the market with containers, some of the use cases that we're seeing, and then some of the security features that we can introduce both with VMs and with our containers as well. So I kind of wanted to start off with just talking about what is the difference between VMs and containers. Hopefully you guys all know this, but with a VM, the biggest, you have your underlying hardware, you drop in your hypervisor, and then each of your VMs, right, each gets its own guest OS, along with the applications that you want to run on top of that. So you basically have a little mini server. It's a full server, all right? When you look at a container, the difference is instead of having the hypervisor, you now have a container runtime, right? So you have your hardware, you have the host operating system, you have a container runtime on top of that. And then each of these containers will actually use the services of the host OS. So rather than having a full OS load, you just have a micro piece of that load, and then it'll use the services of this underlying host OS in order to go run. So kind of the advantages, disadvantages. The advantages here is you have a full OS, a full system, it runs great. Disadvantage, it takes a minute or more to boot, right? I mean, think about booting a server. You're booting a whole OS within this thing, right? So it takes a while. These can be spun up in seconds, right? And you can also typically get, you'll have a certain limited number of how many you can max out before you've kind of maxed out the underlying architecture of your host. You can typically get much more containers on a server than you can VMs as well. So those are kind of some of the pros and cons. Now, in terms of what are the applications, like what are people doing with containers today, and why is this such a big thing, right? So there are hundreds of uses. I kind of narrowed it down into what I see as like kind of the top 5. And kind of listed them, not necessarily in priority order either, right? But the biggest one that I've seen more recently is around cloud native, or using it for microservices, right? So you think about the way a cloud native application works, I'm pretty simplistic, so I think of it like Hadoop, right? I'm basically saying, hey, I got an application that's running, I need to go do a service, so it'll send out a note that says, hey, go give me a service. I can go do that in a container really quickly. Spin up that container, get the information back, send it off, shut down that container, and away you go. So for these where you have microservice architectures or cloud native, containers are really designed for that type of architecture. This is where I think most container work started, right? So when you look back 2 or 3 years ago, most of this is done on the app dev test stuff, or the continuous, what do we call it? Continuous integration, continuous deployment. That is where containers really got their start. So this is where a developer, if they want to test a piece of code, they can send that out to a container. They can run it really quick, get their information, log it, shut that container down. So it's a really quick way to go do this continuous development, continuous integration kind of business model. Also with with multi-clouds, because containers can be more portable, it makes it easier to span those different environments. And then kind of like if you deploy OS agnostic applications, so with Linux you're going to have Red Hat, you've got SUSE, you've got Canonical, et cetera. You've got many different distributions. You can write once on a container and use it in many different places without having to really change a whole lot based on the distribution you have. Now the one thing that does not apply to Windows, right? You can't go take a Linux app and drop it on top of Windows, et cetera. So it's not that portable, but across the different distributions with Linux, they're extremely portable. All right. Now, why AMD for containers, right? So I think there's kind of 3 different things when you kind of look at why AMD. So the first one is around just our sustained leadership that we've had. And I want to talk about that in a little bit more detail as well. Around the container density that we can go drive, and then around the security features that we're enabling as well. So when we talk about, what's our sustained leadership? So you can cut it however you want. You can go look at it at the socket level, at the thread level, the core level, the cluster level. AMD has leadership performance. We've got over 250 world records. We are the performance leaders. We also have leadership in our processes. So we're at 7 nanometers today. We're going to be driving to 5 nanometer with our next generation. That allows us to get the best performance per watt as well. So I can reduce the power footprint within the data center, and that allows for, what did I say? So that allows you to get a lower footprint within your data center as well. When it comes to density, so we've got 64 cores today. We're looking to go to 96, 128, kind of with our next generation as well. And so when you look at the amount of containers that you can put within a given server, we have a sustained leadership here. And this is really most people, when we've talked to them, there's not a strong need for failover capabilities with containers, since you're kind of just using them and throwing them away anyway. So that container density, driving the most containers per node, is a really important feature, and that's where we have a clear leadership in the market. And then on security, so there's a lot of things wrapped around security. We have a whole security suite around, starting with our secure processor that allows you to make sure that you don't have any firmware alterations as you go through the boot process, et cetera, and stay safe there. We also can do secure memory encryption and secure encrypted virtualization, along with some shadow stack protections as well. The one I want to focus on today is around our secure encrypted virtualization. So when I look at it at the VM level, if you're an administrator today and you go spin up a VM, you can go see what's going on in each one of those VMs very easily. And with a simple piece of code, you can go in there and steal secrets, code, passcodes, whatever it is you want to do. Or if one of those VMs actually falls victim to an external attack, that attacker could break out of that VM and into other VMs and even into the hypervisor itself, right? Now, when I implement secure encrypted virtualization, now our secure processor, which is embedded in our silicon, issues a key to each one of those VMs as it's spun up. And it's a unique key. Those keys are owned and managed by the secure processor, not available to or visible to the administrator, the OS, or anything else. So that key is then used to encrypt the main memory space of that VM. So now I've got cryptographic isolation between each of these different VMs, and in the main memory space of these VMs is encrypted as well. So now as an administrator, when I want to go and peer in there, I just see garbage because it's encrypted with a key I don't have access to. And then if one of these VMs falls victim to an external attack and that attacker wants to break into other VMs, again, they just see garbage because it's encrypted key they don't have access to. So it helps protect against both internal and external threats. Now, when we look at containers, you take that same concept, and now I'm going to do it at the pod level, right? So the way this works, right, is you create a pod. So a VM, basically, you create a VM, which is a pod, right? And then you can put 1 to n number of containers within that pod. And then, so similar to how that encryption key is issued to each of the different VMs, you can put an encryption key in each of the pods, right? So now I have this pod. It's got an encryption key. Every container that's in that, so 1 up to however many you want to put in there, is encrypted using that key that's in this pod. And then I can do each pod that I want to go spin up, I can get a separate key for each one of those as well. So now I have, each pod has that same cryptographic isolation, et cetera, as we were talking about at the VM level. Make sense? Okay. All right, so with that, so that's kind of the, why AMD for containers and the security solutions we have. I did want to talk about the solutions that we have with Dell. We've got a lot of really great solutions. On the appliance side, with the VxRail, we have both an E-Series, so it's our single socket 1U. We call it a no compromise single socket because we don't have to compromise on the number of cores and memory lanes and PCIe lanes, et cetera. So one of the things that we've seen in the market a lot is, because there wasn't a really robust single socket, you buy a 2-socket system and you only populate 1 socket. Well, now your memory lanes and PCIe lanes just went dark on that second socket, right? So when we designed our no compromise single socket, now when you put in that, you don't compromise. We still get the full complement of 128 PCIe lanes. You can get up to 64 cores per socket. You still get up to 4 terabytes of memory per socket, et cetera. So great solution for those that are looking for a single socket. And then we have a 2U single socket as well, which allows for more storage. And then on the PowerEdge side, from anywhere from a 1U single socket up to a 2U 2-socket. Oh, and apparently I'm done. Or a 2-node, or even a 4-node and a 2U, right? With great solutions on the vSAN ready nodes, spanning the entire PowerEdge line. Okay, and with that, I'm going to wrap. Does anybody have any questions? Yeah.